So finally, we will look at measuring angles. That is, we will associate actual numbers with angles. The tool that helps us doing this is a protractor. So what we're looking at is called as a protractor. Some of you might have, there's a small chance that some of you might have a circular protractor, even that works. Now, the unit that we are going to use to measure angles is usually degrees. So let me put it this way. How do we measure length? Length we generally measure in centimeter or meter, so on and so forth. Similarly, angles we will measure in terms of degree. Okay, so this is something that we have to remember. Now, let's look at the base with which we understand or we measure things. So, first thing first, there's something called as full turn. What does full turn mean? Say we are pointing towards the right. Taking a turn, one entire turn, that is, we start rotating in say clockwise or anti-clockwise, we end up with the same direction, we said to have turn full turn. For example, let me show it this way. Consider this blue line, right? If I happen to go in this manner, the blue has turned full circle or full turn. Okay, again, this would be kind of half the turn, bit more than half, 3/4 of the turn, and this is one complete full turn. Quite simple, is it not? This full turn, if someone turns full turn, they have said to have turned 360 degree. Okay, so let me show that as well. So we'll go back to our turtle. We will take turtle, we'll make the turtle turn 360 degree. So please look at where it's already turning. It's pointing towards the right, right? Let me make it turn left 360 degree. So you can see it's pointing in the same direction again. Let me make it turn right 360 degree. Again, it's pointing in the same direction. Let me make it turn left 300 so that you guys understand that we are actually entering and it's actually turning. So see, it's pointing towards right bottom corner. Agree? So let me make it turn left 60 more degree. 300 plus 60 will give us correct, pointing to the same direction, 360 degree. Okay, so that is your full turn. Now, what would be the next thing? Straight angle. That is half turn, 180 degree. So if this was full turn, half turn would be half the way. Simple as that. You're pointing towards the right. If you turn by half the way, you'll be pointing towards left. If you're pointing up, if you turn half the way, you will be pointing down. So on and so forth. So let me do this. Now, I've turned towards the right. I'm making the blue line turn half the way and it's turning towards the left. So you can see the approximate value is 180 degree. Let's make the turtle turn, right? I think turtle will make us understand a lot more. So let him turn left by 180 degree. See, it turned towards it was turning right. Now it's turning towards the left. Again, if I turn left 180 degree, where will it go? Present situation is turning towards the left. The new situation would be that it will turn towards the right. Of course, it's not just about left and right. It can be any direction. Okay. Now it's pointing towards right side, right up. Okay. Let's make it turn 180 degree. So now it's turning left bottom, complete opposite of wherever it was turning. So that would be your straight angle, half of a full turn, measuring 180 degree. This is formed when two arms of the angle lie on a straight line. So this is your straight angle that we have already seen. Next is our right angle. So right angle has to do with turning either to the left or right, but pointing in altogether perpendicular direction. Again, this we have seen. So let's again have a look with different perspective. So this is completely 180 degree. It's a straight, almost a straight angle. Now 90 degree has to do with this. Somewhere over here. That's 90 degree. Okay. Then this is also perpendicular. There are two possibilities, right? Okay, let's go to Mr. Turtle or Miss Turtle. So let me go with, let's stick to wherever the turtle is turning. Let's make it turn 90 degree left. Can you see that? It formed a perpendicular. Left. So let me make it, yeah. Now it's pointing towards the right clearly. Let's make it turn left 90. Again, left 90. See, it's now pointing up. Now if I have typed left 90 again, where will it turn? It will point towards the left. Then left 90. Now where will it turn? It will turn to its left by 90 degrees. So it will point down. Then left 90. So where will it point towards now? It's turning left. So it will turn towards the right of our screen. See, as simple as that. So 90 plus 90 plus 90 plus 90, the last four commands will add up to 360. And so it's pointing in the initial direction. Does it make sense? So right angle has to do with 1/4 of the full circle. So some of you might be asking, why is there a 360 value? Where did they come with? So it's human made. The value of 360 is human made. There's a historical context, but again, whatever it is, history or not, it is human made. So we can find it in quite a few places. So modern value is influenced by different sources. But yeah, the 360 value, it has a lot of factors. It has a lot of numbers that it can get divided with. So there is a lot of mathematical aspect also that helps in picking up 360 value. So if you guys want to pause and have a look. So this we will try to make, or not try, we will make a separate video on historical context of different concept, the Indian perspective, and also wherever we have Western or other place getting influenced by influencing a concept, we will add all of that. So yeah, if you guys want to pause and have a read, please do. Okay. Now let's actually measure it. We understood that, we have 360 degree and so on and so forth. Now let's actually measure it. So how do we measure it? Of course, we're using our tool, that is our protractor. So protractor helps us in doing this. So right now, what are the steps? Align the center hole with the angle's vertex. So remember what is vertex? So we have, say, an angle like this. This point is your vertex, while these are your arms. Now, center hole of the protractor. So basically we're talking about this. That's the center, right? Now let's observe few things about the protractor itself so that it should make sense. See, we have 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. So clearly this is perpendicular. 100, 110, 120, 130, 140, 150, 160, 170, 180. Also, we have 0 starting from the left end. And as you can go 30, 60, 90, 120, 140, 160, 180. So it's going both the ways. So when to use what? When to use this bunch and when to use the outer bunch of values, that we'll understand. But you need to know that the values are there at both the ends. Okay. So when to use what, that we'll understand. So align the baseline. So baseline is this line basically. This or this. Basically this two. So align the baseline. Match one arm of the angle with 0-degree line. Read the measurement. Check where the second arm crosses the protractor scale. Use the inner scale if the angle opens to the right, or I would put it in another way. Let me actually show it to you guys. So let me actually show and measure it. Let's measure it. Then it will make sense. So that's our protractor. So we have an angle. First thing first, we need to align our vertex in the center in this manner. Okay. So we have the vertex and the center aligned. Now, technically, we should be aligning the 0 with one of the arms. Since the software does not allow me to do it directly, so I have to go through this. So basically, they're asking us to do this. Okay, so let's zoom in. So can you see that the center and the 0-degree are and the arm, all of them are aligned properly. Now let me take a screenshot. It's much easier to explain that way. So what to observe first is this. Our center of protractor and the vertex, they are overlapping. Next thing that we need to observe is that our arm and the 0-degree line, they're overlapping again. So my funda is start off where the 0 is and start counting where the arm is, right? So the initial arm is pointing towards this 0, so start from there and start counting 10, 20, 30, 40, end where the second arm lies, 50. So in our case, the measure, so this particular angle, this particular opening measures 50-degree, as simple as that. Okay, so let's do one more question. So again, since my software does not allow me to just align everything at one go, I'm doing two steps. One is I'm aligning the 0-degree with the arm and then the vertex, right? Vertex and the center of the protractor. I'm trying to do that. Not exactly the center though, in this case. So we just need to adjust this a bit. It's almost there. Not able to exactly. Okay, now it's kind of better. So as usual, right, this is how it actually looks like. So I'll take a screenshot. We're measuring which angle? Now we're measuring angle ABC. Something like this. Okay, let's look at it. What is the first thing that we need to observe? Yes, check if the vertex and the center of the protractor, they're overlapping. They are. 0 degree, that is, and the initial arm, they're overlapping. Yes, they are. So this is it. Now wherever the 0 is there, right, start from there. Start with that cycle. 0, 10, 20, 30. So this angle measures 30 degree. This is where our final arm is. So that will add to 30 degree. So one more question. So I would want to show another case as well. Okay, here you can see that the angle is not exactly pointing towards the right. The opening is up. So here too, I need to align. I think this is good enough. Yeah. Okay, guys. So let me zoom in. Now screenshot, and we have it over here. We have to go through the same process. Check the centers are overlapping. Yes. Check if the initial arm is at one of the zeros. Yes, it is. Right? It's so. Where the 0 is, it's on the inner circle. So start the count. 0, 10, 20, 30, 40. It's not exactly at 50, but before that. So we have to go to the smaller ones. So we are at 40 over here. 41, 42, 43, 44, 45, 46, 47. So this is 47. So till now we used to use 0, 10, 20 and all of that. But yes, you can have values which are 47, even decimals also. But anyways, that I need not teach you guys for now. So point is, how do we measure, 42 or 43 or 44? How do we do that? Simple. So we are at 40 and the angle is between 40 and 50. So we'll go to the top. So it's between 40 and 50. That's very clear. So 40 and 50. So it's between these two. So this part itself is divided into 10 parts. Like how in your normal scale, you have 10 centimeter, 20 centimeters, 30 centimeters, so on and so forth. But in between that, we have many divisions, right? 10 divisions actually. So in the same way, here too, we have 10 divisions. And how do you count? Simple. 1, 2, 3, 4, 5. So this, you know that even in scale, this mid-size line segment is your 5, then 6 and 7. As simple as that. So in this case, this is measuring 47 degree. Okay. So let's look into one more question. So herein, I will make you guys understand us having an angle pointing towards the left. I think I want to show that as well. Okay, I have the question. So first thing first, we need to keep the protractor in such a way that the center are aligned. But in our case, I do this first. I will align the arms and then the center. That's my way. And then we're looking at, I'll take a screenshot and go over there and explain. Okay. So what is the very first thing? Check if the centers are aligned. Clearly they are. The center of the protractor and the center of the angle, that is the vertex, they're overlapping. And then we have the initial arm. Here, what I want you guys to understand is where the 0 is. So you can see 0 is on the outer circle, right? Semicircle. That's where you start the count with 0, 10, 20, 30, 40, 50. Okay. But it's not exactly 50. It's between 50 and 60. So we'll go to the top division. So clearly, if I extend this, it's 55 degree approximately. So this is 55 degree. So please see the variation there. The other, let me show that itself. It's here only. So here we had to use the inner semicircle. Here we are using the outer semicircle. Can you see the difference? So that difference is something that I wanted you guys to keep in mind. And to verify, you can see that this is where I took the angle from. You can see that it's approximately 55 degree. Close to 55 degree is what I mean. Approximately means close to. Right? And that's how you measure angles.